You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you. Hello, this is Richard Jacobs with the Future Tech Podcast. I have Giuseppe Loianno, Assistant Professor on the Electrical and Computer Engineering Department and in Mechanical and Aerospace Engineering at the Tandon School of Engineering at NYU at New York University. He leads the Agile Robotics and Perception Lab, ARPL. They perform fundamental and applied research in the area of robotics autonomy. So, Giuseppe, thanks for coming. How are you doing today?
Thanks a lot for the invitation. I'm doing very well, thanks.
Yeah, specifically in the realm of robotics agility, we were going to talk about using eye tracking or eye control of drones. Is that what you'd like to focus on today?
Yes, so that's the main topic. So we've been developing this kind of technology for the past year, and so we got some really exciting results.
Well, why control a drone with your eyes? Why not a little remote control that you hold like a RC car? What's the trade-off in doing both?
That's actually an excellent question. We thought that many people are suffering about the ability to really control these machines with external devices, especially with remote controllers. And so basically this is only used today by expert pilots, or it's generally very difficult that a naive user starts to use and is very good at the using a remote controller. So that's why we thought to use basically some eye tracking glasses that gives the ability to the user to directly control the drone using the gaze. So where is looking and where is or her eyes are pointing is the direction that the drone is gonna go basically. The second main reason is also that we really are trying to make these devices and especially these drones accessible to everyone. So it's sort of this kind of eye tracking glasses gives really the idea that you have a sort of drone companion and not anymore a machine that is absolutely far from your understanding.
So, what I noticed that I've tried to use drones a few times and it's very hard to control them, and the sensitivity of the joystick you're using to control it is usually, it takes a while to get used to, and the drones fly all over the place and crash. And if they start to get out of control, people tend to push hard on the joystick and they crash the other way. But with eye tracking, I can see that it would follow the natural motion of your head, and you wouldn't whip your head to one side necessarily to make a correction. So maybe it'll work better. I don't know.
Yeah, so that's the hope. And we also try to decouple basically the head orientation with respect to the real gaze, that many people consider the same thing, but it's actually not, for a better controllability of the platform. And the other really attractive part of this device is that it's really non-invasive. So it's like a normal pair of glasses that people wear basically every day. And so we should really imagine that in the future, most of the glasses will be probably embedded with the sensor suites that these new glasses provide.
Hey, you know what I noticed? I'm just looking around as I talk to you, and it's not comfortable for me to keep my eyes fixed and move my head, nor is it comfortable for me to keep my head fixed and just move my eyes, unless I'm doing eye exercises. So it seems like you need the combination of the two, of head movement and eye position or where the gaze is, because, let's say I'm staring at a lamp and I move my head to the left. It feels unnatural for me to keep my gaze on the lamp. So it seems like the most natural thing is to combine those two. Maybe I'm wrong.
No, no, I mean, you are perfectly right, but the main problem is that the gaze moves way faster sometimes than your head, especially if you point to lateral objects compared to where you are. You basically notice take if you are take your attention that basically it's your eyes are moving first and then your head is moving after them basically. So they have a sort of anticipative information that we wanted to capture in our setup, and so we are able to do that basically.
So what have you noticed? Are you at the stage where you've made prototypes and people are using it and you've observed them in the lab?
So basically, right now we are still at an early stage. So this has been just published in a new paper. We it's working pretty well. We plan to expand to multiple users. So and now we are able to let them to interact with each other. And the other problem, we are also trying to obtain the full 3D information from the gaze, which is actually quite hard. So we can basically send the drone in a direction in space, but we cannot really specify how far. So this information is still missing, and we hope to collect it through new computer vision algorithm, basically.
Yeah, so do you have to combine gaze and head motion or maybe even other signals so you can get full control of the drone? Is gaze
Yeah,
enough?
so the idea is to combine, first of all, to combine computer vision technique like how, for example, you do object detection in the environment and use this detection to basically get a better estimate of the 3D gaze. The other thing we would like also to do is a sort of multimodal interaction. So people, of course, don't only use the gaze information, but they use also other type of information like gesture or like voice. So we would like to combine all these kind of all these types of interaction together in a unique framework. So for better controllability of the drone and for better, let's say, human robot interaction.
Okay, and what, are there certain kinds of drones that this would be more suited for and ones that it's not suited for?
I would say that the approach that we are using is sort of quite general. I mean, it just depends on the user, and it can be extended to multiple types of platforms. So the algorithm that we have developed on the user side are quite general. What we would like also to do is to make some kind of case study to see how people react and how people like feel using this type of glasses. Right now, we have tried on a couple of users, let's say around five, but would like to extend these approaches to also different types of people with different ages to see the difference in the perception of this system, basically.
What kind of tasks seem to lend themselves to eye tracking and which ones don't seem to be good for this?
It seems to be very good to point to a specific location and to understand the human behavior basically without using explicit command like, let's say, the voice or the gesture. So it's sort of a hidden command that's coming directly from the eye, so it's very difficult to perceive from another external user. I would say it's sort of complementary to the other, let's say, ways of interaction. It's sort of less expressive, but at the same time, it's probably more powerful to to position the drone in space.
Is this literally only a one-person control, or I don't know? Does this open up the ability for multiple people to control different parts of a drone so that people fly cooperatively, or is that not even, unintended on your radar?
So yeah, we envision to basically have a complete framework that incorporates multiple robots and multiple humans in the loop. The key idea is to have that human collaborate with each other, but at the same time can interact with those machines to solve a complex task. So this is just the first building block of this entire structure. So we really hope to extend basically the approach to multiple robot first with a single user, so how to control the swarm from the single user perspective, and then to extend the single user to multiple user, and so how basically the drones and the different machines are basically assigned to the user that are part of the task.
Yeah, I'm imagining someone controlling a swarm, and then a second person comes in, and the part of the swarm breaks off, and the other person controls it. I guess there's all kinds of interesting things you could do.
Yeah, it's sort of interesting because at that point you have multiple agents that have to collaborate together. The drone is the one that you can literally basically control. The human can also run, can also walk or like perform some kind of task by themselves, and then the drone can compensate for what the human is not able to do as a sort of companion, basically, and. The main thing is that this machine can accomplish with humans cooperative task. Let's say mapping an environment, so that can be accomplished in faster way, both from the human perspective and from the drone perspective. And also the drone can be sent ahead in space or in region that the human doesn't know, to give a first overview, and so that there are safe to identify safe paths for humans to enter, for example, in a building or after a natural disaster. So we should really imagine these drones as helping ourselves during normal life and not anymore as enemies.
Wait, I just realized something obvious. If I'm controlling a drone by looking at it, that's totally different from me seeing through the drone's camera and controlling it as if I am the drone, as if my eyes are in the drone looking out. How do you reconcile that, or what do you find is best?
Yeah, that's a good question. Actually, this is the looking through the camera of the drone and controlling it is becoming a sort of sport. So that's like FPV pilots. I wouldn't say that for now this can be for sure reconciled. I mean, if you think about virtual augmented reality device that have also the gaze ability, you can basically think about reconstructing the environment using, for example, the headset from the human's headset, but also using the camera from the drone. So the user can basically have a perspective, a new perspective in his or her new world, that is a combination basically of images and maps that comes from his own exploration, and that also comes from the drone exploration. So this can increase actually the human capabilities.
Well, what happens if you're controlling a drone and it goes out of line of sight? Do you switch to, onboard drone camera mode? I don't know. It just seems, I don't know. Can you have both of those in your view at the same time? Would that confuse you? It just seems like a difficult problem or puzzle.
Yeah, so that's certainly a difficult problem. Out of line of sight, you should certainly probably switch to the field to the camera view. But within the line of sight, you can probably also use a combination of both, but not showing the image to the user, but showing a new world that is a sort of combined map, combined 3D reconstruction done from the user perspective, but also from the drone perspective. So the human basically has an open world in front of him that shows a much larger area reconstructed to increase basically his or her situational awareness.
Well, what if you paired a drone with a follower that kept at a certain distance, and its only job was to mimic the first drone, stay a certain distance away, and have its camera trained on it? So when you go out of line of sight, that camera takes over, and you still are getting a pseudo line of sight, view of the drone, but then you can still switch to that drone's particular camera, the main drone, and see things close up if you want.
Yeah, that's definitely an option. But the main problem is to use the camera of the drone. Many people needs lots of hours of training, and this is still like some kind of concern for naive user. So using the camera of the drone is certainly an option, but it's not something that people feel comfortable or ready to use it as a first experience, basically.
Yeah, that's what I'm saying. Maybe you need a follower drone for people that, it's a much lower threshold for training versus using the drone's camera.
That's definitely an option.
So what's the holy grail for you? What kind of experience do you want to create for users, and how long do you think it's going to take you to get there?
So I think the experience we want to create is that first of all the drone has to be sort of a companion for the human. So I would like that the drone, for example, is able to enter into a building with the human, and the human receives directly feedback. Meanwhile, he's pointing to different areas, receive directly feedback about the structure, for example, of the building, about if there are some critical parts that needs to be replaced and that needs the human intervention, such to facilitate inspection and basically mapping tasks that right now are basically just executed by expert people by working in this area, or by people that know how to control manually a drone. This is, for example, also the case of bridge inspection. So many people send expert user to basically look at the bridge manually, or they have some kind of pilots that send the drone directly, they pilot the drone around the bridge. But a third case would be basically to have a user that uses the gaze to drive the robot around the bridge, and at the same time receives feedback online about the current status of the bridge and what needs to be replaced or maintained in the near future.
Well, very good. So what's the best way for people to find out more about what you're doing, and maybe watch videos of it, or when could they get the device itself to do the eye tracking?
So the device, I believe, is already available online. We'll post mostly of the algorithm probably within the next couple of years. This is like a long process. It's a research that just started. The latest update will certainly be found on my website. That's the Agile Robotics and Perception Lab, and on the DCIST website, that's the new program that is sponsoring actually this type of research.
Very good. And is there any other way to get in touch with you, or your lab or department, to ask questions or give ideas?
Yeah, so my personal email is loiannog@nyu.edu, so people are really welcome to email me directly. There is a news page directly on my website that includes also the latest video, the latest release in terms of algorithms, and also the latest collaboration that we have in addition to the main research areas that we focus on. So gaze tracking is just one of the multiple works that we are carrying on at NYU, basically. And we have also affiliated to the lab a YouTube channel that you can find directly on the lab website.
That's great. Well, Giuseppe, thank you for coming on the podcast. And it's interesting to see all the implications of what you're working on. So keep up the good work, and thank you for being here.
Thanks a lot for your time, and thanks a lot to everyone for listening.
You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you.